Hello people, in this video let us look at some formulae which are related to the screening test. Okay, so if there is a screening test, basically it is a basic test, right, to just check if the person has the disease or not. This will be a cheap test. You can do it on many people and it will be less time consuming, but this is not a confirmatory test. Confirmatory test you will have to do after this. So a screening test, let's say something like a mammography or a breast self examination or an ELISA, all these are screening tests, right? So let us say that you get a screening test as positive. It does not mean that you have the disease unless you diagnose or confirm. So let us say we have a screening test, okay, and these are the diseased people. In diseased people, which are like total 100 people have disease, only 80 people get a positive on a screening test and 20 people will not get a positive. That's really bad, right? They will have disease and they'll go back home without knowing that they have the disease. Now healthy people, now let us say you have healthy people of again 100 people. In that 40 people will come as false positive. Though they don't have the disease, they will get a positive result on a screening test, and 60 people will go back home happily that they don't have the disease, and actually they do not have the disease. So let us look at these terminologies called sensitivity and specificity. Okay, first understand this table, guys. So guys, what are we looking at? Screening test. In screening test, we have tabulated the results, okay, of the disease and the healthy people. We want to know if this screening test that we are going to use is sensitive and specific. We want both of these values to be really good because we don't want to miss out diseases, right? We don't want to wrongly categorize healthy people as diseased, or we don't want to leave out the diseased people as negative. So basically, we want to test whether this screening test is good or not. Okay, so now we know exactly who's diseased, exactly who's healthy, we know it, and the screening test, we will see the result of the screening test, positive, negative. We have put these values in here. Now what is sensitivity? Guys, let us start off with sensitivity. Sensitivity is the true positive divided by the total disease into 100. So true positive, how many you got? Okay, so as usual, we always keep in this table A, this will be A, this will be B, this will be C, this will be D. We always write like this only, right? For even odds ratio, etc. So always A, B, C, D. Now, sensitivity formula is true positive divided by the total diseased people into 100. True positive means what? Here you have A divided by, who are all the people who have the disease? This entire thing, right? A plus C. A divided by A plus C into 100 will give you the sensitivity. So true positives out of total disease will give you the sensitivity. You want this value to always be high. You want this value to be high. You want this value also to be high. Remember, you want true positives and true negatives to be absolutely high, right? So sensitivity is a measure of true positivity, and specificity is a measure of true negativity. So true negativity means true negative out of total healthy. So true negative out of total healthy, that is D divided by B plus D, will give you specificity. So you want specificity also to be more. Okay. Nice that you understood sensitivity and specificity, guys. So sensitivity and specificity, you understood. Sensitivity is true positives, specificity is about true negatives. You want both of these values to be high in a screening test, isn't it? Now let's move on. There is something else called as positive predictive value and negative predictive value. Same thing only. Positive predictive value, you will use the true positive. Negative predictive value, you will use the true negative. A and D. You're always using A and D, isn't it? A, D, always using A and D, and denominator is changing. Let us look at this positive predictive value. It is A divided by A plus B into 100. That is A divided by A plus B. A plus B is everybody who got positive, right? Positive predictive value is A divided by all the people who got positive into 100. So the true positives divided by total positives into 100. Similarly, negative predictive value is true negative divided by total negative into 100. Okay, negative predictive value, true negative divided by total negative into 100. Did you understand positive predictivity and negative predictivity? Positive predictivity is true positive divided by total positives into 100, always into 100 only in this video. And you have true negative predictive value is true negative divided by total negatives into 100. If you are not sure, look at this, D divided by C plus D. So D divided by C plus D. So true negatives divided by total negatives will give you negative predictive value, NPV. Now don't break your heads, just last one slide will show you. Look at this. Proportion of false positive to proportion of false negative. Only here you have false, and it is very clear. We want proportion of false positive and false negative. Which is false positive? B. Which is false negative? C. You're not sure? Go back to the table. Let's check. False positive is B, false negative is C. Till now we never use these values in the numerator, B and C, right? So now we will check. False positive means what you will do. Take the false value on top and divide by what? B plus D. B plus D is the total healthy people. So how many false positives you got amongst healthy people? That is the proportion of false positive. Similarly, proportion of false negatives. How many negatives did you get among diseased people? Oh, that's bad, isn't it? These two should be less, isn't it? You don't want false positives among healthy people. You don't want false negatives among total diseased people. You don't want negatives in diseased people. You don't want positive among healthy people. This is proportion. Proportion of false positive should be less. Yes, false positive should be less. False negative should be less. Understood, right? These two should be less. Let us look at this from the beginning now. Screening test. So sensitivity, specificity, you understood. Sensitivity is true positive divided by total diseased. Again here it is total diseased, remember. Sensitivity, denominator you're getting total diseased. Similarly, in the last one you saw total disease. Proportion of false negative. Right? Okay. Anyways, going back here, sensitivity is what? Total positives among the diseased. You want this value to be high. Specificity is total negatives among the healthy. You want this to be high. Positive predictive value. Do you want this to be high? Yes, you want A to be high and D to be high. So obviously you want positive predictive value to be high, negative predictive value to be high. You want all these to be high. Finally, coming to this proportion of false positive, proportion of false negative. Obviously false, false. You don't want these to be more. Proportion of false positive and proportional of false negative for a screening test. You don't want them to be more. Here false positive amongst the total healthy, false negative amongst the total diseased. Okay. So this completes 6 formulae in screening test. In screening test, we have finished 6 formulae. Okay. That's all for now, guys. You've looked at what and all? Sensitivity, specificity, positive predictive value, negative predictive value, proportion of false positive, proportional of false negative. That's all for now. Bye-bye.